use a software auto clicker, right? It's super easy. Also lazy and boring. It's so boring that I already wrote one in C while I was complaining about how boring it is. This is boring. Wow. I want there to be a loud clacking noise. Doctor's orders. I want to make a real, live mouse. Computer mouse. So how's this gonna work? I guess we'll start by taking it apart. And here is the mouse. If I probe the switch with my multimeter set to continuity mode, you can see that when I push the switch, all it does is short across the switch. Alright, so I've analyzed the circuit and I've created some technical documentation. As you can see, don't worry if this looks too complicated, by the way. We have a switch, and when I press the switch, it closes the circuit. Now I know it's really complicated, but I think we can hack that. Alright, I've modified the schematic by adding a new switch. This switch is a switch that switches when electricity switches it by passing through the switch. The electricity is switched by a switch in the switch computer. I added another computer, don't think about it too hard. If you're familiar with electronics, you might be thinking of this thing. This is a relay, and it's basically the same thing as a switch, except instead of my finger controlling it, it's electricity that controls it. Yes, leaded solder is much easier to work with, but it also makes you stupid. I'm going to start by controlling the relay with the microcontroller. Everything's all connected properly. Microcontroller controls a relay, which switches the left mouse button, all connected on the bottom. Let's write some code. So I programmed the microcontroller to click the relay 10 times a second. And again, the relay is controlling the left mouse button, so we should be able to see that on the CPS counter. Ooh. Very nice. Here I'm cleaning up the circuitry a little bit and putting a knob on it so that I can control the clicks per second in real time without having to go back and program it again. In order to save some space, I put the display on top of the Arduino. You can see it's not touching, but it is barely touching the button, which technically means this is now a touchscreen. Boom. That was the... The device is ready. Let's turn it on. Okay. 1 CPS. Looks good. CPS. This is about the limit of human clicking. Let's push it. Something's up with it. Something's up with the gauge? 45. It's holding steady at 33. 50. It dropped. What? Okay, so it looks like 36 is the max that I can achieve with this. 40 CPS isn't that bad. That's probably good enough. I can do better. The relays working fine. The problem then has to be with the mouse. I have to build my own mouse. Alright, got a new microcontroller. This should be able to directly interface with my computer. This circuit works great for proof of concept, but I think we're past this. We have a new microcontroller which acts as a HID device, which interfaces directly with my computer. It can act as a mouse and send mouse commands. Piezo buzzer, because we still need the clicking functionality. RGB LED, because this is a gamer product. It needs to have rainbow vomit lighting. A bunch of switches here, just for controls. This should be the finalized circuit. I'm gonna create a PCB for this because I don't want to deal with wiring this. That's gonna be a disaster. Once I've made the PCB, I'm gonna put it inside of a box like this one. This is just to house all the controls in a neat manner and look freaking sick. Here's the PCB design. This is my first time using KiCad, so this is a good learning experience. I crammed everything onto a single layer to make manufacturing it really easy. To create my PCB, I'm going to use a technique called photolithography. I have a resin printer which can produce detailed UV light imagery, and I'll use this to project an image of my PCB onto the substrate and then use that for the development. This mask is this green substance on top of the copper sheet. The development process is called positive photoresist. What this means is I create a mask, and whatever is hit by light ends up getting washed away in the developer. I then use an etchant called ferric chloride to dissolve the copper wherever there isn't a mask. In doing so, I can carve out traces and planes using just light and a couple of chemicals. I'll have to manually drill out all the holes. I'm using only through-hole components, so installation should be easier. Finally, I cut the board to size. Here's the finished PCB. I'm going to start installing components onto it now. Test number 1. 5 CPS. Looks good. 10. 20. Test number 2. Let's try and beat my previous record. We're hitting it. Test number 3. Until it breaks. 101. Reading's a bit higher. 250. More. 500. It's reading an order of magnitude higher. Let's go higher. 3,000. We can do more. God, come on! Come on! I did it. I actually did it. Hey, I'm actually really happy with how this thing turned out. I did not expect it to work that well. I kind of tried to do something a little different with this video where I'm trying to explain some of the technical details but add some dramatized elements to keep it interesting, you know. I'm still a pretty small channel, as you can probably tell. So if you enjoyed this, please consider subscribing. I've definitely got more on the way. In any case, thank you very much for watching. Catch you in the next one.